The run instruction in a Dockerfile is fundamental for executing commands during the image build process. It allows you to install software, configure settings, and perform various operations necessary to set up your application's environment. You can install different softwares and run different commands during image build using this instruction. The basic syntax for the run instruction involves specifying the command you want to execute. There are two main forms, the shell form and the exec form. In the shell form, you simply provide the command as a string, such as apt-get update. In the exec form, you provide the command as a JSON array, which allows you to explicitly define the executable and its parameters. For example, executable perm1 perm2. The shell form is generally more convenient for simple commands, while the exec form is useful when you need more control over how the command is executed. A common use case for the run instruction is installing software packages. In this example, we're using apt-get to install Python 3, Python 3 pip, curl, and Git on an Ubuntu or Debian-based image. Note the use of and to chain commands together, ensuring that each command is executed sequentially. Also, the flag Y automatically confirms the installation, and apt-get clean removes unnecessary files to reduce the image size. Besides installing packages, the run instruction can also be used to execute arbitrary shell commands. This example shows how to create a directory, add a user, change file permissions, and write text to a file. These are common operations performed during image creation to set up the necessary environment for your application. For example, make directory /app, user add ms/bin/bash app user, change mode +x/app/script.sh, echo, hello Docker, greater than /app/message, txt. For complex commands, it's often helpful to split them across multiple lines for readability. This can be achieved using the / character as a line continuation marker. This example shows how to install multiple packages using apt-get, while keeping the Dockerfile organized and easy to read. Run apt-get update and in / apt-get install y / git / vim / notages / npm and in / apt-get clean. To optimize your Dockerfiles and create efficient images, follow these best practices when using the run instruction. First, chain commands together using and to reduce the number of layers in your image. Fewer layers result in smaller image sizes and faster build times. Second, always clean up the package cache after installing software to further reduce the image size. This removes unnecessary files that are no longer needed. Combining commands with and is a powerful technique for streamlining your Dockerfiles. This example shows how to download a file, extract it, move the extracted files, and then remove the temporary files, all in a single run instruction. By chaining these operations together, you ensure that they are executed sequentially and efficiently, minimizing the number of layers in your image. Run change directory /tmp operator and continuation, get https://example.com/app, third easy operator and continuation, tar flag xef app targ easy operator and continuation, move app opt operator and continuation, remove flag rf/tmp/*. Setting the working directory within a run instruction allows you to perform operations in a specific location. This example shows how to create a directory, navigate into it, clone a Git repository, and then change the ownership of the directory, all within a single run instruction. This ensures that all subsequent commands are executed in the correct context. Run make directory flag p/app/src operator, and change directory /app operator and git clone https://github.com/repo, git operator and change own flag or app user /app. There are several common patterns for using the run instruction in Dockerfiles. One pattern is to update, install, and then clean the package cache in a single run instruction. Another pattern is to install build dependencies, compile your application, and then remove the dependencies in a single run instruction. These patterns help to create efficient and optimized images. When a run instruction fails, it's important to troubleshoot the issue effectively. First, check the exit codes of the commands to identify the source of the failure. Use set to ensure that the build process fails immediately when a command returns a non-zero exit code. Second, debug the steps by running the commands individually to isolate the problem. You can also check intermediate containers to inspect the state of the image at different stages of the build process. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.